Section 10.2 here in this video. We got a couple problems left to look at. One being finding the angle between two vectors, and then finishing up with an application problem. Here's what we've got. Angle between two non-zero vectors can be found by this formula here. And on top here what we have is the dot product. And then on bottom is you're dividing by both magnitudes. And then that is equal to the cosine of the angle, so we would end up doing cosine inverse of the decimal that we would get here. Okay, so let's go ahead and look at this first problem. We've got, divide this here in sections, so number 9 here, we've got cosine of angle theta would equal the dot product, so the dot product between u and v. Dot product would be 6 times negative 2 plus 1 times negative 1/3 plus negative 3 times 1. Alright, so this is negative 12 plus negative 1/3 plus negative 3. So that's negative 13 1/3, or 15, excuse me, negative 15.333 over magnitude. So the square root of, so let's do the magnitude of u. So it's 36 plus 1 plus 9. That's 46. And the magnitude of v. So now we're looking at here. The square root of 4 plus 1/9 plus 1, which is 46/9. Use a common denominator and add those together. So when you do this inverse cosine of all of this, then in degrees you get 180 degrees, and that's your answer. That's the angle between those two vectors. So let's try example 10 now. So we would have cosine of our angle theta equals, let's do the dot product, so we've got negative 2 plus negative 15 plus 0, and that's negative 17, over the square root of the magnitude, 4, 9, and 0 is 13, and the magnitude of v is 1, 25, and 1, that's 27. Inverse cosine of all of this. So what we have here is 155.15 degrees. And there's your angle. Alright, that's how you find your angle between vectors. Last thing that we're going to look at is an application problem. We have a 500-pound weight is supported by 3 ropes. So if we can imagine this here, we've got 3 ropes. We've got a weight here. It's being supported. The weight is located at the origin. Okay, so here's my origin. And the points, so this is P, let's say, Q, and R. R as follows: 202, 222, negative 2, negative 1, 1. Find the force or tension on the rope, or on each rope. Well, we've got some vectors here. So the first thing that we need to do is figure out each of these vectors. Well, if this is the origin and each one of these points are from the origin, then these are also just our vectors here, P, Q, and R. I'm changing those to vectors since we're going, the initial is the origin. We can subtract 0, 0, 0 from all 3. What is the vector that represents the weight? Well, the weight, it's being pulled down here. Our weight vector would be 0, 0, and negative 500. It's the z value, because the weight would be pulling directly down in our 3-dimensional space, and since it's being pulled down 500 pounds, using negative 500 for that measurement. What are the vectors that represent each rope? Well, each rope has a vector here, so it's, let's call vector u, we'll attach that to P, so 202. And the next vector is 222. And z is -2, -1, 1. Now what we need to do though is we need to find the unit vectors for each one of these. So the unit vector here for u would be 2 divided by 0 divided by 2 divided by, well, the magnitude of the first vector is the root of 8. So 2 divided by the root of 8 divided by the root of 8 divided by the root of 8. This simplifies down to, because the root of 8 is 2 roots of 2, so this is 1 over the root 2. 2 square root of 2 over 2 reduces down. This is 0 and 1 over the root of 2. We're going to do that for all three of these vectors. So this vector would be 2 over, the magnitude of it is 4 plus 4 plus 4, so the root of 12. For all three of them, 2 roots of 12 on bottom, 2 divided by the root of 12. So this vector will equal, so it's 2 divided by 2 roots of 3. It's 1 over the root 3 for all three of them. So I basically created these vectors, and now we're finding the unit vector for each one of them. Still got the last unit vector left. All right, we've got 2 here, -2 over, the magnitude is the root of 6. So -2 over the root 6, -1 over the root 6, and 1 over the root 6. There's our three vectors. Now here's what we've got to do. We have to take these three vectors, they're unit vectors, and what is unknown about the unit vectors is their force. So if I multiply this unit vector by a force of u, and this unit vector by a force of v, and this unit vector by a force of z, I just need to figure out what does u, v, and z equal. Okay, so I'm going to go ahead and transfer over some of this information and we'll continue to solve this. All right, so here's what we've got. These are our three vectors. So this vector times some sort of magnitude or force in all three of those. So u, v, and z, that's what we're actually going to solve for. What I need to do here is I need to distribute them. So I'm going to distribute the u through, and this is what we would have. So 1 over the root 2 times u, comma, 0, comma, 1 over the root 2 u. And we've got 1 over the root 3v for all three of these. And times z. So in order for us to find u, v, and z here, I need to use a system of equations. Well, my system, though, needs to have three variables, u, v, and z. So each one of these columns here will represent a different equation. So that's how I'm going to set up my system. So I have my system of equations is 1 over the root 2u plus 1 over the root 3v plus -2 over the root 6z equals, and we're going to come back and talk about what it equals in a second. So each one of these is my equation. I have 0 here, so I don't need anything over there. 1 over the root 3v plus a -1 over root 6z equals, in the last equation, the last column, 1 over the root 2u plus 1 over the root 3v plus 1 over the root 6z. Now here's what they're all equal to. Let's go back to the other page. We've got our vector, and all of the weights, all of the x-coordinate weights have to add to 0, although the next variable has to add to, or the position has to add to 0, but the last one would have to add to a total of 500. Not -500, because we don't care about the direction it's going, but just 500 pounds. So this is what it's equal to. This is our first component right here. Our first component, all those should add to 0. This should add to 0, and the last one should add to 500. So we're going to solve this system. Now I recommend solving this system using matrices. So this is my matrix multiplied by my variables u, v, and z. This will equal my answers here. My answer matrix is 0, 0, and 500. So what we've got is, in a matrix form, 1 over the root 2, 1 over the root 3, negative 2 over root 6. You guys can put this into your matrix. This is 0, 1 over root 3, negative 1 over root 6. You get the idea here. Go ahead and solve the system using inverse of A times B. So inverse of A times B. This would be your A matrix, this is your B matrix, and then you'll be able to get your solution. And your solution is U is equal to 235.7 pounds, V equals 288.7 pounds, and Z equals 408.2 pounds. And there you have it. So those are each of the 3 ropes and the tension. Here's your assignment for this section.